The first step in the maintenance process is to perform a preliminary cleaning of the outer surface to prevent debris from entering the engine. A basic compression test by pulling the starter cord to feel the resistance of the piston inside the combustion chamber. We need to remove the top protective cover to directly access the air filter and spark plug. Squeeze the safety throttle lock and test start it to check the equipment's initial ignition status. The engine fires but emits abnormal smoke, indicating that the air-fuel mixture or the ignition system is having issues. Buying a similar used machine from a local mechanic is the optimal solution to source genuine replacement parts. With the negotiation complete, this donor machine will provide the ignition module we need. Agricultural work environments always have high humidity and lots of mud, which demands absolute durability from the machinery. Mechanical repairs often take place in parallel with the natural pace of rural life. Observing the fluid flow is much like how we analyze the chainsaw's guide, bar oil pump line. It must be clear and unobstructed. Basic creativity using raw materials is the foundation of all modern mechanical engineering. Load-bearing structures in construction also share similar principles with the alloy frame of a heavy-duty chainsaw. Specialized tools need to be carefully transported to the site to ensure precision during disassembly and reassembly. The technician approaches the work area, bringing specialized tools and replacement parts. An open space is the ideal environment to work on internal combustion engines, to avoid exhaust gas poisoning. The weight of the chainsaw and toolbox requires an organized layout. Before beginning engine surgery, setting up a field workstation requires a stable, flat surface so that parts and screws don't get lost. Occupational safety is paramount. Long hair must be tied back tightly to avoid getting caught in the engine block or flywheel. Remove the carburetor cover clips. This is the first step to diagnose the air intake chamber and electrical system. The standard toolkit includes a spark plug wrench, a hex wrench, and a carburetor adjustment screwdriver. Visually inspect the air filter and spark plug contact area to see if there are signs of short circuits or electrical leaks. Unplug the spark plug boot from the high voltage terminal. This action must be decisive to avoid breaking the carbon core. Inside, use a specialized hex socket to loosen the spark plug counterclockwise from the cylinder barrel. The spark plug electrode is covered in thick black soot, which reduces its ability to emit high-intensity sparks. Use a dry cotton cloth to wipe away excess oil from the threads of the spark plug to prevent thread stripping when reinstalling. The ceramic insulator is not cracked, but this carbon soot layer acts as a resistor, blocking the electrical current. The standard spark plug gap is typically between 0.5 and 0.7 mm. If it's too wide, the voltage from the IC won't be enough to spark. Ground the spark plug casing against the engine block, then pull the starter cord to visually test for a spark in the light. Since no spark appears, we will rule out a faulty spark plug by replacing it with a brand new one. Use a new spark plug with the correct temperature specifications to optimize the combustion chamber performance of this high-revving chainsaw model. The new spark plug features a heat-resistant alloy electrode, ensuring stable ignition under extreme pressure. Remove the protective plastic tube from the threads. The new threads will help the metal gasket compress tightly, ensuring an absolute seal for the cylinder chamber. Always thread the spark plug in by hand for the first few turns to feel the threading. Absolutely do not force it with a wrench. The engine compression is excellent, but the machine still won't start. This confirms the fault lies deep within the IC ignition module. The frame and cooling system must be completely disassembled to access the flywheel magneto on the right side. Prepare a metric hex wrench. This is an essential multi-purpose tool to disassemble and reassemble professional chainsaws. Before opening them up, use a brush to sweep away sawdust stuck around the cooling, fins to prevent debris from falling into the engine components. The choke and carburetor areas are highly sensitive to dirt. Thorough cleaning ensures safer disassembly and reassembly. Proceed to remove the 4 hex bolts securing the starter cover assembly. and the recoil starter unit on the side of the engine. The manufacturer's torque is quite tight, so firmly hold the hex. Key perpendicular to avoid stripping the alloy bolt heads. Removing the starter cover reveals the magnetic flywheel assembly, which generates voltage pulses for the ignition coil. Gently detach the starter assembly. Be careful not to let the recoil spring pop out. Inside the starter pulley, use a small flathead screwdriver to double-check the fuel and air. Mixture needles on the diaphragm carburetor. The L needle adjusts the low-speed air-fuel mixture, while the H needle controls fuel at the maximum engine RPM. The T screw centers the throttle valve for idling. Improper calibration will cause the engine to flood or over-rev continuously. Disconnect the spark plug cable assembly and the kill switch wire to free up space for dismantling the upper engine block. The plastic locking clips protecting the cylinder barrel are designed to withstand heat. Pry them open carefully to avoid breaking the locking tabs. The choke rod system is directly linked to the regulating choke valve. This aluminum joint needs to be disconnected. Use your hands to gently lift the back cover after opening all the hidden latches. Below is the cylinder assembly, cast from an aluminum alloy. Once the cover is removed, the entire ignition IC unit, located right next to the flywheel cooling fins, is completely exposed. Use a hex key to remove the reinforcing nuts on the right side of the engine block to get enough space to access the ignition IC. A chainsaw's structure is very compact. Every bit of space is maximized. To reduce the carrying weight for the operator, the accumulation of sawdust, soaked in oil over time, forms a hard crust that obstructs the cooling airflow to the cylinder combustion chamber. Every single cooling fin slot must be scraped clean. If cooling is poor, the cylinder barrel will overexpand, causing the piston to seize. 1. Switch to a soft brush to clean the rubber intake manifold area. Absolutely do not let any debris fall into the carburetors. Venturi throat. 2. A mechanical expert understands that the cleaning phase accounts for up to 50% of the success in an engine restoration job. 3. Moving to the clutch cover and chain brake area. The sawdust mixed with lubricating oil creates a very annoying sticky jam. 4. Remove the guide bar cover to check the drive sprocket and see if it has worn beyond the permissible limits. Use a metal pick to scrape out the oil groove on the guide bar. A clogged oil pump hole will burn out the chain after just a few minutes of cutting. The bar groove needs to be smooth so the chain drive links can slide with minimal friction under the centrifugal pull of the high-revving engine. 4. The rotating sprocket nose of the bar also needs to be cleaned, so the roller bearings inside do not get jammed tight by packed wood dust. 5. Unplug the cables from the old ignition coil IC unit. This component is responsible for amplifying the voltage up to tens of thousands of volts. Over time, operating at high temperatures, the internal copper coils of the IC often suffer internal breaks, leading to a complete loss of spark. Take the ignition IC unit from the donor machine from earlier. This is an original replacement part, ensuring the machine operates as smoothly as possible. Visually inspect the magnetic steel legs of the new IC to ensure there is no rust that could reduce magnetic induction with the flywheel magnets. 1. Test fit the length of the high-tension cable and ground wire to ensure the engine kill switch circuit is connected accurately. 2. Loosen the bolts securing the old IC. The subsequent magnetic calibration requires precision down to tenths of a millimeter. 4. Lift the broken IC unit out of the engine mount. This magnetic module harvests energy from the rotation of the flywheel, the permanent magnets on the flywheel. When sweeping past the IC coil, will generate an induced current to fire the spark plug. Thread the bolts through the mounting holes of the new IC. Liquid thread locker must be used. If the machine frequently vibrates heavily, lightly thread the bolts into the aluminum block without tightening them yet, so that the calibration step can still be performed. The air gap is extremely important. Plug the circuit breaker wire connector, the kill switch, into the negative terminal of the IC, so the ground current can kill the engine when needed. The copper core of the high-tension lead needs to be in contact perfectly with the clip spring of the spark plug boot. Thread the cable through the waterproof rubber cap, water or sweat. Intrusion will leak 20000V to the engine block. Tightly insert the metal core straight through the heart of the electrical cable to maximize the transmission area for electrical pulses from the copper core. Pull the rubber cap up to completely enclose the metal jaws. At this point, the spark plug. Boot is completely insulated from the outside. The entire IC ignition coil. Assembly has been completely wired and is ready to be installed on the engine frame. The chassis ground connector must be secure because vibrations at 10,000 revolutions per minute can loosen the connector. Position the magnetic face of the IC toward the outer edge of the flywheel. Incorrect orientation will alter the ignition timing. Insert a standard thin piece of cardboard, about 0.3, thick, as a gap gauge, for the air gap between the flywheel magnet and the IC magnetic poles. Rotate the flywheel so the magnet pulls the IC tight against the gauge cardboard, then proceed to fully tighten the two mounting bolts into the aluminum block. The tightening torque must be even across both bolts so that the magnetic plane of the IC is absolutely parallel to the flywheel's axis of rotation. Pull out the gauge cardboard. The strong magnetic field has precisely shaped the optimal air gap for power generation. Manually rotate the flywheel a few times to check for smoothness. Absolutely ensure there is no occurrence of any physical rubbing. Mount the pull starter assembly back onto the engine block. Ensure the pulley pawls engage perfectly with the inner flywheel grooves. Use a hex key to align and hand thread the bolts into the threads to secure the starter cover, avoiding misalignment with the rotation axis. Tighten the bolts in a cross pattern to evenly distribute the mechanical clamping force, minimizing the risk of deforming the cast aluminum alloy casing. The clutch cover surface is the center of the transmission system. Any binding will reduce the chain's cutting performance. Clean the automatic chain brake mechanism thoroughly. This safety latch must work perfectly to protect the operator when the saw kicks back. Connect the high tension cable to the spark plug and pull the starter. The solid feedback force indicates that engine compression has been restored with a strong and stable electrical spark. Now we need to synchronize the air-fuel mixture through the carburetor. Fine-tune the L screw. Low speed by adjusting it a quarter turn at a time, so the machine achieves optimal acceleration from idle to full throttle. Unscrew the cap of the chain bar lubricating oil tank. The oil pump will draw this fluid and distribute it evenly along the chain through the narrow groove of the guide bar. Install the protective cover for the cylinder and spark plug. The gap design of the cover helps direct the cooling airflow longitudinally across the fins. Tighten the system of heat-insulating plastic screws so that the engine compartment is completely isolated from dust during operation. The spring clips, for quick operation, allow the operator to easily maintain the air filter foam right on the job site without needing any tools. The chain filing process requires the specialized round file to be placed exactly at a 30-degree angle relative to the cutter to sharpen the cutting edge most effectively. Double-check the tightness of the cover seams. The extreme vibration of the chainsaw will destroy any loosely fitted parts. Use a cloth soaked in solvent to wipe away oil and grease residue on the fuel tank area, as a dirty casing will hide micro cracks, if any. Standard starting procedure. Engage the safety throttle lock, step your foot to firmly hold the handle, squeeze the trigger, and pull the starter cord decisively. The engine block roars powerfully. The new ignition system provides a powerful spark, restoring the original power to the cutting machine. Proceeding to analyze a basic hydrodynamic model through the object's interaction with the flow, evaluating its ability to maintain water resistance and the buoyancy of the handcrafted structure in narrow flow conditions. Process. Recalibrating the aerodynamic parameters on the sail, scaling it down to optimize thrust, conducting an experiment to measure the flow velocity by simulating the movement of the object, tracking its trajectory. The technician begins the diagnostic procedure, organizing the system, and gathering specialized tools for mechanical intervention. They start the battery-powered impact driver, a core device for the rapid disassembly of load-bearing bolts, equipping protective nitrile gloves to prevent corrosion from industrial chemicals, and ensuring hygiene. Proceeding to remove the drivetrain's protective cover to reveal the sprocket and chain structure needing maintenance. They perform an initial visual inspection to assess the degree of physical wear on the surface of the metal components, checking the free torque of the roller axle to determine the binding of the bearings and brake mechanism, pre-cleaning and disassembling adjacent parts to remove dirt and prevent contaminants from entering the system. Test operating the equipment on a slight incline to evaluate the responsiveness of the drivetrain. Observing the urban lighting system, the luminous fixtures, operate stably in low light conditions. Analyzing the synchronized movement of the subjects, a form of kinetic energy that is rhythmically released. Spatial coordination with the umbrella structures creates mild air resistance during the rotation cycles. The centrifugal motion of the umbrella canopies shows a perfect distribution of the center of gravity on the central axis, a test of dynamic balance. As the subject navigates a lever-like object back and forth, the pneumatic pressure generated by the airflow impacts the vibrating diaphragms to emit basic audio frequencies. Detecting a technical issue on the main drivetrain requires urgent intervention and assessment. Receiving information about the error condition, analyzing the potential causes of performance degradation. The process of moving the equipment by towing. Since the independent drivetrain has lost its ability to function, the technician approaches the new repair location, preparing to implement standard troubleshooting procedures. Opening the tool tray, taking inventory of the modules and equipment needed for disassembling the mechanical structure, selecting a hex socket that fits the size of the bolts on the load-bearing system's protective cover, attaching the socket to the impact driver's spindle, ensuring the locking jaw is securely fastened, checking the operation of the brushless DC motor, confirming counterclockwise torque, activating the impact driver to release the tightening force of the axle retaining bolts. The removal process takes place rapidly, moving to the second bolt position, applying impact force to break the threaded connection, stuck due to rust, completely removing the anchor points, isolating the protective cover from the equipment's main frame, intervening in the front sprocket area, removing the cover screws to expand visibility into the drive chamber, detaching the lower load cover, freeing up space to proceed with measuring the slack of the metal chain links. Cleaning impurities, adhering to the support shaft's surface with an industrial cloth to prevent cross-contamination, performing the procedure to change into new protective gloves, to transition into the phase of working directly with grease, checking the tail section, positioning the support points to ensure the equipment maintains absolute static balance. Removing the upper protective cover, the entire drive chain system is now exposed, ready for the in-depth analysis phase. Using hands to feel the lateral play of the drive chain, assessing the wear level of the pins and rollers, checking the engagement between the chain links and sprocket teeth, detecting any basic deviations in chain pitch, comparing the load-bearing surface area, identifying carbon deposits, and mud tightly compressed under pressure, swiping along the length of the linkage chain, detecting stiff links due to a lack of lubrication over a long period, extracting needle nose pliers from the toolbox, preparing to intervene with the master link to remove the entire chain, locating the retaining clip pin, a component responsible for connecting the two ends of the chain into a closed loop. 1. Use pliers to apply compressive force to the head of the retaining clip, pushing the clip to slide out of the groove. On the lock pin, gently. 2. Successfully separate the master link clip, carefully. Remove the outer side plate to release the internal link pins. 3. 1. Completely push the master link pin out of the structure, interrupting the continuity of the drivetrain. 2. Pull the chain, sliding it off the sprocket. Remove this component completely to proceed with cleaning. An overall replacement. 3. Place the chain on the ground. Assess in detail the degree of stretch and the level of rust of each individual link assembly. 4. 1. Prepare a specialized solvent-based cleaning chemical to dissolve stubborn grease deposits and metal oxides. 2. Begin the mechanical scrubbing operation, using an abrasive tool to break down the thick layer of grime around the rollers. 3. 4. Apply friction force along each link, driving out debris from the microscopic gaps between the pins and the chain body. Prepare a rotary polishing tool attached to an impact driver, setting up an automated abrasion mechanism. Activate the high-speed spinning motor, generating strong centrifugal force to blast away impurities, adhering to the surface of the rear sprocket. 4. Concentrate the friction force into the grooves of the sprocket teeth profile, where a mixture of iron filings and burnt lubricant accumulates. Set up the chain breaker, a mechanical leverage tool used to press the rivet pin out of the axis of the damaged link. The mechanical pressure from the advancing threaded shaft under impulse force has successfully pushed the steel pin out of its casing. 4. Retrieve the breaking tool, inspect the metal punch pin to ensure it isn't deformed after experiencing high stress. 5. Remove the excess linking section, preparing to assemble the drive chain with its now optimized circumference. 6. Align the components of the master link, ensuring the integrity of the retaining clip before complete installation. Perform a free spinning test on the idler wheel axle, analyzing mechanical resistance and rim runout. 4. Clean the tire surface, optimizing traction and removing foreign objects that could cause dynamic imbalance. 5. Realign the chain onto the rear sprocket, ensuring the rollers fit completely into the sprocket teeth profile grooves. 6. Pull the two ends of the chain together on the face of the static sprocket, preparing to perform the final locking of the master link. Pass the U-shaped pin through the open holes, reestablishing complete cohesive integrity for the loop of the transmission system. 4. Attach the retaining clip with the open end facing opposite the direction of mechanical travel, preventing the lock from popping off due to friction. Wipe clean any droplets of abrasive solvent left on the drivetrain assembly, protecting the alloy surface coating. Check the cyclic movement of the chain links, evaluating the slack at the midpoint to set the tension. Perform adjustment on the rear wheel axle, balancing the distance on both sides of the cam adjusters to achieve standard technical specifications. 4. Proceed to restore the protection system, positioning the lower drivetrain cover accurately into its retaining clips. Hand tighten the mounting bolts initially to ensure the threads are not stripped, establishing the initial centering connection. Check the tightness of the protective cover edges to eliminate acoustic resonance phenomena when operating at high RPM. 4. Brush off the surface of the mudguard shield, a finishing step aimed at ensuring aesthetics and easy visual inspection. Use an impact driver to apply the final vibrational tightening force, securely locking the component blocks with high torque. 4. The process of tightening bolts in confined spaces requires the mechanic to have absolutely precise rotational axis positioning skills. Use physical compressive force to estimate the air pressure inside the tire, confirming the safe load specification. 4. Completely remove impurities adhering to the exhaust heat shield surface, preventing burning odor incidents due to high temperatures. Clean the shock absorber coil spring, removing soil and sand deposits to preserve its elasticity coefficient, the linearity of the shock absorbers. Check the entire wheel axle linkage assembly to ensure there is no mechanical displacement under torsional force. The technician gets on the vehicle, activates the central electrical system, and prepares for the final dynamic assessment. 4. The engine transmits power through the drivetrain that was newly restored, operating smoothly. The torque response reaches optimal levels. 5. The technical procedure is completed. All mechanical equipment and solvents are neatly arranged into the dedicated storage compartment.